Everybody awake?
I don't know. Steven, are you with us?
Yes, Senator.
Okay, guess what we're going to talk about, Steven?
We're going to talk about propeller heating.
Propice. Not Popeye, Propice. Okay, so you guys are going to study a lot more in de-icing systems in second year, but because it's attached to the propeller, I'm going to cover it now. And that's what we're going to do. So Propice, accumulation of ice. Accumulation of ice causes the loss of it, causes the loss of airfoil shape. And that's true for the airfoils on the wings, the airfoils on the empennage, and the airfoils that make up the propeller. So the loss of the airfoil shape, and it adds a lot of weight, which causes imbalance. And adds weight, which on props anyway, which causes imbalance. So now the props start shaking all over the place, and that's not a good thing. Let's see. Interesting thing is icing. Icing does not usually occur near the outer sections.
Is that because of centrifugal force?
Yes, you ruined it for me. Near the outer sections of the prop. Much the way the paint slides off, so does the ice. Near the outer sections of the prop due to centrifugal forces. Due to centrifugal forces. All right, when we talk about icing, anytime we talk about icing, we have to talk about two types of systems. And this holds true for airframe as well. So two types of icing systems. And this doesn't make sense that I called them icing systems. I could say of not icing systems, or getting rid of ice. And I'll show you why.
De-icing.
I can't say that. And there's my problem. And I'll tell you why. Because there is anti-ice, which you think, oh, that would have been a good word to use. And there is de-ice. And those are two different systems. So as the names sort of indicate, anti-ice, it prevents. It prevents accumulation of ice. Accumulation of ice. And de-ice, it removes ice. Removes ice once it is built up. Once it is built up. So, for example, we talk about wings. Wings are really, or airframe systems really get more into the anti and the de-ice, and it's very clear. So, one of the anti-ice systems that you can have is they actually have like a fluid that will come out of little tiny holes and weep onto the wing, and it keeps the ice from forming. And then one very common de-ice system is you have the wing leading edge, and there's a bladder, a rubber bladder that actually is glued to the front of it. And this rubber bladder actually has, when it inflates in little sections. Like it'll inflate here the first time, and then the next time, and then these sections will deflate, and then it'll inflate a section here, and then that'll deflate. And what happens is when these inflate, it breaks off the ice that was created and gets rid of it. Now the problem here is, I'll make ice this color. If you were to run this system and these are inflating and deflating, inflate and and the ice started to build up, it could potentially build up out here and creating a little tunnel or a cavity or cave where all these things are inflating and deflating and the ice never breaks off. So it's really important that you let some ice build up, then you turn it on, break off the ice, then turn it off, right? So that's a de-ice. And then again, anti-ice could be something like a hot leading edge or some sort of fluid. So propellers do kind of the same thing. It's just one of the things they don't use is this boot system here, which confuses people because they look the same when they're installed. So people see boots on the leading edge and go, oh, well, that's a de-ice boot. It's what they're called. And it inflates and breaks off the ice. And then they're going to see these boots on the propeller and go, oh, well, I know what that is. Those are de-ice boots, and they inflate and break off the ice. And to that, I would say, well, how exactly are you going to get the pneumatic air out there? Let me pull up some pictures here. Let me see, back where we were. There we go. I'll just pull up this picture. So you see these boots right there and you go, oh yeah, that's the pneumatic boot. And I'm like, well, how do you get the air out there? Well, I don't know. Yeah, well, you gotta have really long hoses that wrap up around here, I guess, and then you have to unwind them. So that doesn't work that way. So these are not pneumatic boots, but we'll talk about that just a little bit. So we'll go back up to where I was. There we go, from current slide. Get rid of this. Bring this back up. There we go. All right, so we have the de-ice and anti-ice. So let's talk a little bit about the first one I've got on here, which would be the anti-ice. Anti-ice. And that is to get rid of the ice. Don't let it build up to begin with. So the way you do that is with a fluid. So we're going to use anti-ice fluid. So you don't want to wait until you get a whole bunch of ice built up and turn this on. You want to turn it on when you suspect that you're going to get a buildup of ice. And so it's going to use one of two fluids. One of them is isopropyl alcohol, ISOPROPYL, isopropyl alcohol, ALCOHO. That's good stuff. The downside is flammability. You don't really want to spray something that's flammable all over the front of a hot engine, but that's what it does. Number two, so to speak, is a phosphate compounds type, PHOSPHATE, phosphate compounds. It's not as flammable, but the downside is cost. Apparently the stuff is not very cheap. So anti-ice must be used before, I'm going to say formation of ice, but you get a little bit of ice, that's fine. So use before the formation of ice. Formation of ice. Anti-ice does not melt formed ice. So it's not going to melt the formed out ice. So how does it work? What is it? I'm glad you asked. So the way it works is it is going to spray anti-ice fluid onto the propellers and direct this onto what is called an overshoe. And that overshoe is really just a rubber boot. So you see this rubber boot on there and go, oh yeah, that must be the anti-ice boot. Now it's just called the overshoe in this case. But you have a tank that is going to be filled with either that phosphate compound or some isopropyl alcohol. Of course, you have the filter, the pump. The purpose of the switch or rheostat, a switch would be something that's on off. A rheostat is something that controls the speed of the pump. So let's say you're getting into some icing conditions and it's predicted to be a very light ice, just barely any, and you're like me and you're just slightly a paranoid person, then you're going to turn this on, but turn it on real low and just keep an eye on things. And then if you get into some heavy icing conditions, I should back up. If you're paranoid like me, you don't go into icing conditions. But anyway, back to that. So, and if you encounter more heavy icing conditions where it really is starting to ice, then you want to turn that pump up and keep the ice off the props. So the fluid comes through the tank, through the filter, over to the pump, and through the feed pipe. And what this is showing right here, and it's drawn quite well. I should go to I think, is there's a little cup. And so the pump just sprays it into this cup. Because remember, the propeller is going around in circles and you can't have something that's connected to it. So you got to have a slip joint in there somewhere. So this thing just sprays it in this area. And because of centrifugal force, the fluid is going to set down in this little tray, which you have to remember, this is only 2 dimensions. The tray is 3 dimensions. And it will go into the tray, and the tray, then it'll slide around until it gets in the tray. There's a hole drilled for each blade. So in this one's gonna be 2 holes drilled. The fluid will find that little drilled hole and a new pipe, and it'll follow down that pipe and then dribble onto the shoe, the overshoe. I always forget, I always just call it the shoe, onto the overshoe. And the overshoe is nothing more than a piece of rubber that has grooves in it that direct the fluid down the path to the blade. So let's see, I got more pictures. So, oh, she could have just done that. I guess that's what I was thinking. So there we go. So just an enlarged picture. I just took it and enlarged it. So there we go. So this right here is the feed. You can't see the cup in the back, but here's the feed line coming out right here. The feed line right there. And it goes on the overshoe, and I know it's a bad picture, but you can see all the little grooves cut in there. And in the grooves, just take the fluid and direct it kind of to go evenly down the blade and disperse itself rather than just going in one simple little line and then leaving one area of no ice and areas of other ice. So that's just, that's how that works. And that's all there really is to that. That's all I got to say about that. All right. So what do we got here? 1, 2. Oh, I'm up here. So that didn't make sense. So 3. Operation. So 1, a tank that stores the fluid. The fluid is plumbed to a slinger, so slinger ring at the prop. The slinger ring is going to collect the fluid. So the slinger ring collects the fluid, and through centrifugal force, sprays the fluid onto the base of the blades, A pilot control, which we can call a rheostat, that's the rheostat, R-H-E-O-S-T-A-T. The rheostat will vary the amount of fluid, we'll say amount of fluid released, released to meet conditions, to meet conditions. Let's see, I'll go right back to that. Hang on, no panic. Right here and right here, they're not labeled, but those are check valves. And the check valve is a spring-loaded valve that is supposed to prevent fluid from going backwards. Well, we don't really have a problem with fluid going backwards. I don't know if check valve is really the right thing to say. I think I was going to draw something and show you what the inside looked like. I would make it look more like a sniffle valve. So I would have, we'll just take that, enlarge it. We'll just put a little lump right there. I'll put a ball in here with the spring going to something. And so what happens is the fluid pressure has to build up to push the ball out of the way to get it around. Otherwise, if you had an open line all the way through the pump and the filter, you're gonna have a negative pressure behind this propeller right here. And so that negative pressure would constantly be sucking right there and it would suck the fluid right out. And that would be a bad thing. So you don't wanna do that. So I'll say a check valve, check valve that opens at 3 to 5 psi, prevents fluid from being sucked out of the tank. Prevents fluid from being sucked out of the tank. All right, and then we have feed shoes. The feed shoes are rubber boots. Rubber boots with channels that direct fluid down the blade. That direct fluid down the blade. And the feed shoes only cover about 1/3 of the blade. They're just down there at the root, blade root. All right, the last thing we're going to look at, last system is the de-ice system. So de-ice, de-ice system. We just had anti-ice. Now we're going to look at de-ice. And the de-ice system, it's actually quite simple, even though this drawing makes it look like it's not simple, is heated boots. And the problem with the heated boot system, what makes it a little bit more complicated to try and understand, even though it's really a simple system, is that you can't just heat all the blades up and leave them on. They have rubber boots on it that have, it's waterbed technology, but you guys are mostly too young for waterbeds. It has heating elements that are going to heat up the blade. And so it's, in theory, you can think of it this way, it draws too much current to run all of the blade heaters at the same time. So what they do, and we'll look at this, we'll look at this top area right here, and this represents a twin engine aircraft with two bladed propellers. So you have in total 4 blades. So We could say this is the right engine, right prop, left engine, left prop. And it has been divided up into 4 sections for each prop. So I have a total of 8 sections. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so problem number 1, you can't heat all the blades up all the time at the same time. So you got to sequence it. Little heat over here, little heat over there. All right, the second thing you have is that you're getting electricity from the aircraft engine or the aircraft itself to a propeller that's spinning around. And you can't have wires that wrap up around it. So you got to have some way to transfer this electricity from something that's spinning to something that's not spinning. And that's really simple. It's no different than how you would do it inside of a generator or an alternator. Alternator is actually more accurate. And you just use slip rings and brushes. So that's what this represents right here. We have a wire, and don't worry about this right here right now. We'll talk about that later. So we have a wire that's coming in, and it's got a carbon brush, and that carbon brush, I'm going to zoom in a little bit. Hang on. Yeah, I'll zoom in. I was looking at one of the pictures I have. So that carbon brush is touching this ring is touching this wire, and this wire works a certain heating element within the propeller. All right, and then this wire comes to another one that it contains and heats up this certain element in this propeller. And then this one right here is as you can see, it's the ground wire, because you got to have a ground, otherwise you don't have a continuous path. So this would be heating element 1, heating element 2, and the return path from each heating element to ground. So we could say that heating element 1 heats up, was it this section up here? Heating element 2 is this one right here. And it's going to do the same thing over here. So it's like heating element, this, I got to get out of here so I can draw and see how I'm curious how they drew it, if it was semi-accurate or not. So let's see. So this heating element here comes up and it heats up. Looks like this section right here heats up. And that one is running around to this one, which comes around. Yeah, it looks like it's outer. Oh, sorry, it's over here. So outer, outer, inner, inner, outer, outer, inner, inner. All right, so you have to heat them up individually is where I'm going, erase all. Okay, so we've got it heating up individually. Now, the other thing is you have to figure out, how do you make it heat up intermittently? Well, that's what this all sequencer right here is for. So this right here is nothing more than like an old timey, as say your grandparents or me, you know, my grandpa had one, had a light in a living room on a timer. And all it really was is just a very slow clock that went around. It was mechanical. And so this is just a clock that goes around, but it moves faster than a clock, but slower than the second hand. And so wherever this is pointing is whatever gets power. Right over here. So if you follow it through.
Can the pilot control where that's pointing if one needs it more than the other?
No, you cannot do that. And you'd never know, because remember, these props are spinning faster than you can see it. So you could never say, well, it seems like the outboard of my left prop needs it. You would have no idea. All the pilot can do is speed it up or slow it down. And then there is one overriding thing, which we'll get into. So switch, I don't know what the heck that switch looks terrible, but you could speed it up or slow it down, but we'll just go through it. So the sequencer, so right now it's going to go through here and out. Actually, we can go, well, it's kind of weird how they show you.
Outboard.
Yeah. So right now it's going to go to this side and go outboard, outboard. And it's going to heat up the right prop. And then it's going to come around and it's going to go, I think then it comes down here, inboard, inboard. So it's right prop, out, out, in, left prop, out, out, and in. And then it comes back around and starts again over here. So out, and it's just going to sequence it through like that. Now inside of the cockpit, there's an ammeter. For those of you that have electricity, you should remember that an ammeter measures current flow, therefore it is in line. And so what it is actually measuring is how much current is flowing through here. If this little needle was right in between here and not here, the ammeter, and you should know this, says 0 because there's no current flowing. So you can actually watch the ammeter flicker as it goes between station and the reason why it does have to ammeter, because you don't really care if it's drawing current or not, but it tells you it's on. So if you have these on, then you're going to show current flow. Now here's the thing about that. Here's for you as a mechanic, and that's great for the pilot. As a mechanic, we have to check these things on an annual inspection. And this is where things go bad. So the way we always did it is we used two guys. One guy got in the cockpit, turned on the master, turned on the prop de-icers, and another guy stood out front and would feel the prop and call it out. Prop outer, inner, outer, inner, got it, turn it off. And the guy in the cockpit would do nothing more than make dang sure he turned it off, or she, because if you leave this on and you don't have an icing condition, which usually is the case in the hangar, then these boots are going to overheat and burn up. And then you got to replace the system. And that's going to be really expensive, because usually you send it to a prop shop and they say, well, can't do that without taking the blades off and doing an overhaul. So you have to be really careful with that. There have been a lot of windshields. Windshields use kind of the same thing, little heating elements through them. Mechanics leave them on when they check them. So the number of stories I've heard of systems like this, and especially windshields getting ruined, are excessive. So things like this, where you can only leave them on for a little bit of time. That's why I say use two. One guy, the only thought in his head was, don't leave this thing running. Don't leave it running. So, but really, once you look at it and you kind of dissect it, it's a very simple system. You just have to understand what it's doing, and then there it is. That's, I think, oops, I have one more picture. It's really, because it's so simple, there's not much else to show you. It's so simple. So this is just one of those systems. So here's the heated boot, and it doesn't go very far, because remember, ice gets flinged off out here. By the way, there's the prop governor. And so here's the wires coming through. Now, these wires right here are attached to the spinner bulkhead. So you know these wires are spinning. So that means that the brush plate and brushes are back behind the starter ring gear support, because this is all spinning around. And those are those horrible, terrible to safety nuts on the Macaulay prop. All right, there's my de-ice. So you may have indicators. One style, like this is Beechcraft, they actually have amps. Now they're going to give you some information. This one over here doesn't have amps, but it's an ammeter. It just has low and high and a green spot. So this one I think has a green spot right about in there. So it doesn't tell you how many amps. You don't worry about it. It's either high or low, because you can control how fast it sequence. And there's also like an override, I think, that actually feeds heat to all of them. Like if you kind of were taking a nap and then woke up, some of them have the ability to override the sequencer and actually just heat all of them up at once, because it's kind of an emergency situation where you got caught not paying attention. But this is a nice plane. It has de-ice props. It's got, this is my favorite item right there.
Air conditioning.
Yep. That's all I care about. All right. So, oops, I'll leave that up in case you were still writing. So where am I here? De-icing, that's what I was going to talk about. De-icing. So allows, is that what I want? Yeah. Allows ice to form, then removes it. Well, you don't necessarily have to let ice form and then remove it with this system. The problem though, if you don't have ice, the boots overheat. So allows ice to form, and then removes it. And then.
So basically it's like an ice regulator.
Yes. Accomplished by the use of heated boots. Heated boots bonded to the propeller. As ice, well, I'll say, wait a minute, as boots heat up, boots heat up, ice is melted at the surface, at the surface of the boot, actually, of the boot, at the surface of the boot, and thrown off by centrifugal force, and thrown off by centrifugal force. All right, operation. So when system is turned on, when system is turned on, current travels from the control unit to the brush block. Current travels from the control unit to a brush block, It's called a brush block because it has brushes in it, and the brushes are made out of carbon, which transfer electricity, so, to something that's moving. The brush block that rides on a rotating ring. Rotating slip ring. Power is then sent from the brush block. I already said that, from the brush block, but sent from the brush block through the slip ring, sent from slip ring to heated boots on prop. Well, they're heated now. Three, the blades have bonded. Blades, I already said this, have bonded. That means glued. Bonded heating elements. Heating elements that heat with current flow.
How often you change those?
I don't want to ever change them. I hate doing that stuff. When they start to delaminate, okay, it's going to depend greatly on their use and where the airplane is stored. So if the airplane is stored inside a hangar, not that often. The plane is outside, it gets baked by the sun every 5 years or so.
How many amps usually transfer to the props?
Well, based upon this gauge right here, I'm going to say somewhere around 15 to 20.
Just enough to melt the ice.
Yeah. Because the heating elements.
Kevin, I have another question.
Yeah.
So you showed that picture with the AC. What is it called when you get like the approved data to put something on your plane? Is that a possibility? Can you put AC in your plane?
No, I don't think so. An STC is the word you're looking for. And I wouldn't do it to my poor little plane because it's too much weight and not enough power. So this is not an aircrafty story, but I'll tell it to you so you can get caught up. But when I was a kid, I started our house on fire. Now you're like, oh, please do tell. So my stepdad was the type of individual who he was notorious for saying to me, you know, He wanted things done very exact, according to his exact wording. There was no room for ambiguity. So you did exactly what he said. And if he didn't, this is always a funny thing. If I would say something, well, I thought, I didn't, you know, there's no thinking. You do what I say. And then if I did something stupid, he'd say, why'd you do it that way? You know, and I would, you know, you need to use your head. And I'm like, well, a minute ago, you told me not to. So that's the kind of kid I was. And so I was a smart ass. But anyway, so I had a water bed because, you know, I'm that old. And my water bed got a hole in it. And if you guys have never had a water bed, I'm looking at Harry because Harry seems like a water bed kind of guy. He probably had a van too with a water bed in it. But
Not at
Oh,
all.
wow.
do you have a
Never
water bed,
had.
Harry?
Nope.
Wow. Okay. So,
Yeah.
so I don't know. If you guys never had a water bed, there's nothing more uncomfortable than an unheated water bed because the water has to be at least above your body temperature. Otherwise, it's incredibly uncomfortable and you won't sleep. So, but anyway, so there's this heating element. It's the exact same thing as what we're talking about. You have current flowing through a little strip. So I had this big water bed developed a hole in it. So we hear this, you know, sounds like the dog peeing on the carpet because no dogs are allowed in the house. I knew that wasn't it. And I'm like, oh crap, my water bed's leaking. So, you know, and I go get my stepdad and I said, water bed's leaking. So, you know, it's getting late. We got to drain the whole water bed out. And so he gets it going. He's like, well, I'm going to bed. You drain the water bed. And I still remember this day said, and turn the heater all the way down. And I thought to myself, I really would rather unplug it, but I'm not going to get in trouble tonight, man. I'm just going to do exactly what he said. I'm going to turn the heater all the way down. And it was winter time. So the house got pretty cold. The water bed, I drained it out, took the mattress out. There's plywood and then the heating element. I turned it all the way down. I went to sleep in the next bedroom over. And then the smoke detectors woke us all up. And he comes running out of his room at the same time around my room. He opens the door to my room where my waterbed was, and the oxygen hit and boom, flame on. And it was just all flames. And they died down pretty quickly. And I forget exactly how we put them out, but grabbed a fire extinguisher or something. But of course, you know, it's one of those conversations. Why didn't you unplug it? And I said, because your specific words were to turn it all the way down. I thought that was pretty stupid myself, but I followed directions. So I tell you that story to tell you, you know, just to tell you how my life was. My stepdad and I, we get along very well. He's a pretty cool guy now. We just don't mean to make him sound like a bad guy. He's not. But it's the same thing. You know, these heating elements, they get really hot. It's hot enough that it actually started the wood on fire in my bedroom because there was no mattress there. So that's why you don't want a waterbed. All right, because the heating elements draw a lot of current, there is a sequencer. A sequencer to heat only one section at a time, to heat only one section, ION, section at a time. Oh, I probably don't need to go. I had an example. I'll put left outboard. Well, I'll just do it. What the heck? It takes me longer to tell you why I don't do something. Example. So, and the reason why I want to do the examples because I'm going to use a different word. So left outboard, and then it goes 1 second null. Null means off, so 1 second null, and then it's going to go left inboard. 1 second null, and then right outboard, and then 1 second null, and then see how the sequence is going to go. I don't have to keep writing it. So I'll write over here. So B, each element is heated 15 to 30 seconds. See, boots. Boots that become overheated can delaminate. Boots that become heated can delaminate from the prop. Do I have more room? Nope, I'm at the end. Optional modes may include full ice. So maybe a switch that says full ice. So that's a spring-loaded switch that must be held on, and heats all blades at once. So that was what I was telling you about, but you got to hold it. So you can't turn it on and walk away. As a pilot, you physically got to take one hand off something, hold it to this full ice position and hold it there until maybe if the vibration goes away. Thing about ice is you can usually hear it leaving because it's going to hit the fuselage when it flings off. So you have to hold it on there the whole time. And then the other was you may have a fast cycle, or you may have a slow cycle. So that may be your options. You may have full ice, fast cycle, slow cycle. And the fast cycle, of course, is going to make that the sequencer go around faster so that blades are getting more heat more often. And the slow cycle will keep it so that it goes from one to the next in a slower cycle. All right, I'm dropping a pin. Boom, I'm done.
I'll be damned.
That was a lot.
So now what?
So,
I don't know. I never got to the end of it before.
how many instructor quizzes are you gonna put?
Well, it depends on where I left off. Actually, I did
Propellers.
The way that it would work in the normal class was there's a prop 1, prop 2, and then prop auxiliary. So usually it ends up being, this is always a short week anyway, the last week of class. So I usually do this as just a thing. So I think I'll do 1 or 2 more.
We did prop 1 already.
1 for each section. Where did I leave off?
You've had quizzes up to module 5.
All right. Well, I'll do module 6 and 7. That's all I got left.
Just as long as we do the review.
All right. What else?
No module 8, right?
I'd have to look. I don't have my stuff numbered. All right. Propellers. This is old. Just a big fan in front of the plane used to keep the pilot cool. When it stops, you can actually watch the pilot start sweating. Anybody care to guess what this funky green thing is?
Looks like a blade hold.
It's an anti-theft device. You try and start that airplane up with that on there, it's going to, as a friend of mine used to say, Smitty, it's going to shake like a dog passing a peach pit. Ain't going to go anywhere.
I thought it was a sweatband.
Yeah. It's a Live Strong band for the airplane. Anybody know what kind of plane that is?
A badass plane.
I was about to say something like that.
It's maybe a Starduster or I don't think it's a Pitts. I think my guess would be a Starduster if I had to throw money down. I don't know. Home built. All right, what else we got here? Oh yeah, there we go.
Oh, single blade prop.
I never seen that.
Well, that's because that one's Photoshop. That's not real.
I was gonna say I see the other counterweight.
You have to have no. That is, looking at that looks like a gull wing Stinson, if you ask me. Look at those wings. So a Stinson Reliant. What kind of prop is that? You should know.
Oh, 2 position.
Yep, Hamilton Standard 2 position, or if you said Hamilton Standard 2 position, you'd be wrong.
Dang it.
If you said a Hamilton Standard constant speed, you'd be correct. Why?
And that's a steel body,
What is that?
steel hub,
Yep.
governor.
Because it has parts exposed.
Constant speed. Yep. Probably this. No, that one has aluminum. The only one I know that has a steel hub is the ground adjustable.
Oh,
All right. So yeah, that's not real. That's real. That's a real one-bladed prop, and it was the Germans who experimented with that, and it's supposedly the most efficient, but I don't know.
Yeah, I saw that.
is that just a 2-cylinder engine?
No, it's 4.
Oh no, it's 4.
It's I don't know what the heck this is. It's just crap I stole from the internet.
I like the Chrysler Prowler in the background there.
Oh, nice. I know. Sometimes that's what I usually pay more attention to in the background. But that's it. All right. So lunchtime, then we'll come back and review, and then we'll be done.
Oh.